start off, this is me. I'm leading a lot of AI efforts at the NEAR Foundation, specifically on go-to-market, strategy, partnerships. Previously did a lot of investments and pretty much everything else that is not core engineering. And so just a quick disclaimer, everything here is not financial advice. A lot of these future-looking statements, don't take them to the grave. This is just to kind of give you the lowdown on what we're building. So this is the quick overview, but to start, like, why is NEAR doing AI is because, again, we want the user on internet, but we have this protocol. So the first step of building this was to build a distributed database that scales, because we need to have a state machine that not a single person can own. And this took about 6 years to build. Fortunately, we did it. The box was checked. We have over 34 million monthly active users. We've done the thing, and now it can scale forever, which is pretty cool. Second step is make sure all blockchains can seamlessly interact with each other. That is near intense. If we only push everyone to our global state machine, we don't think that's going to be successful long-term, so we want to work with everybody. And then once we have chain abstraction sort of checked, then we get to user-owned AI. And so this is what I'll be talking about today. Some quick stats. NEAR Intense is crushing it. They just hit $9.5 billion in volume. The fees are working. We kind of have a money printer these days, so that's very exciting. And I talked to you a little bit more about the NEAR protocol stats. So it's a lot of zeros, but right now we need to make sure that, I kind of already talked about this, and it's going to be a completely new paradigm. So we do believe that, right now you have your browser and there's the payment processors and you access websites, but instead in the future, you're going to have your AI assistant that communicates with this intense network that you essentially indicate what you want. This thing understands everything that you like, and it actions on your behalf. And so it actions on your behalf through open source smart contracts where everything, again, is verifiable. And so NEAR sits in the middle of that. But right now we are currently giving all of our data away, and the app is pretty much taking it and training with it, and it's stored for a very, very long time. And we see a world where you actually just interact with the app, your AI assistant interacts with the app, and you keep all your data. And there's ways to ensure that no data is the data that you don't want to be leaked is actually leaked to the model. And so, yes, but we need privacy at the foundation of all of this. And so in order to build trust, that's the ultimate goal. And the way we do this is through the confidential compute hardware. So who here is familiar with trusted execution environments? Raise your hand. Okay. For those who are not, think of it like a black box. You throw something in this black box, you can't see what's going on inside of it. Nobody can. And every time that something happens inside this black box, it gets stamped by the hardware. And so you now have this stamp saying, hey, this action was made in it. And so what we do is we run oh God, my slides are a little bit everywhere, but you'll get to it soon. What we do is we run open source models inside of this trusted execution environment that is now made available on the GPU, which is very exciting because it was historically only on the CPU. What this means is you can run larger models inside of this black box. And so you can have a prompt, encrypt your prompt, send it to the black box, decrypt it inside of the black box. It gets stamped along the way, and then you can run inference on the prompt that's now decrypted. Once you take that, you run that inference, take the answer, send it back to the user, encrypted. The user decrypts it. Now you've been able to prove privacy along the entire path. It's pretty cool. So now you can chat with your AI, and you can prove, because when I say you can prove, all those attestations you get back as the user. And so then you can go to the attestation service and check to say, hey, Intel said that this is right, NVIDIA said that this is right, and, now you built that trust, which is very exciting. And this is a huge market. So this all came out last February, by the way. TEs on the GPU. And there's only a couple of companies that are really focused on this, NEAR being one of them. And Gartner, I'm familiar with Gartner, like the giant, okay, great. They made a report on confidential compute recently saying that it's going to grow to about a $50 billion market in the next 4 years. That's insane, considering it just came out like about a year ago. And so we are one of the first movers in this space, and using this TEE infrastructure in a lot of different ways. It's not just inference, and I'll get into that shortly. So there are other systems that exist, so you can run everything locally. That is incredibly expensive. Right now, I'm managing a lot of the hardware that we're procuring from partners, and it's like dozens of thousands of dollars a month to pay for some of these machines. And so everyday people are not going to be able to run large models on their local devices, but you want to get the most powerful ones. So with our solution, you are able to get the most powerful open source models and assure privacy. And I want to emphasize the open source models for now. OpenAI and Anthropic, I bug them every day to give me their model weights, and they're not down. And so right now, the only option is to really use this confidential compute stack. And so the really other cool thing is that if you're a lawyer, you're an accountant, or you're a therapist, there's no attorney-client privilege or privilege in the legal sense that AI companies have. So if you send if a law firm is using AI in their day-to-day work, and the U.S. government or some government wants to subpoena OpenAI to get that data, they can just give it away. While if you were just working with a law firm, you have attorney-client privilege. This is a very important thing. So if you're talking to a therapist, there's laws saying the therapist can't just go leak all your, sensitive conversations to a third party, but the AI can. And so there's a couple industries where AI is not even allowed to be used. And so these are the markets that we're currently going after. We do have a consumer-facing chat, but right now I think the bigger total addressable market is in the enterprise and governments and others. So I'll get to that shortly. So with the TEEs, you get the confidentiality because everything's encrypted. You get the verifiability because you get the attestations that you're able to check. And then it's now available on the GPU, and you can run pretty much anything inside of these models or inside this hardware, which is really, really cool. And I kind of explained how this works, but yeah, you essentially throw anything into a Docker image and run it inside of the TEE. Shout out to the Follow Network team for building this really cool thing called DStack that enables you to do this. And now there is a bit of a overhead for encrypting and decrypting consistently. It's about a 5% cost overhead and a 5% performance overhead. And these are just some graphs to show that. This was made about 6 months ago as the space, is just changing so quickly. We are actually getting much better performance, and I actually see this gap going to continue to decrease. At the end of the day, this is going to be commoditized. Every hyperscaler is going to eventually have confidential compute enabled, and because it's just a huge liability. Now, I do want to flag that the private inference, what you're protecting is your information leaking to the inference provider, not necessarily the front end. So if you're a developer, you instead of giving all of your information of your users to an OpenAI, you can still keep that information if you wanted to, but and you're ultimately liable. The person who's running the front end is liable for the activity that's happening in the app. What you're doing is making sure that you're not leaking that information to external players, i.e. the inference provider. And so this is live. We currently support a bunch of different models. We actually just supported GLM 4.7. 4.7 GLM, most people don't know the state of open source models these days, but it feels just like ChatGPT. And that's really cool. Like, we're getting to this point where open source models are pretty much the same to a lot of closed sourced. And this is really exciting because now we can do things like code generation, PDF ID, like all this really cool stuff, just like you can use in OpenAI. And so we also have like GPT-OSS, that's OpenAI's open source model, Kimi K2, and again, everything is private. So you get this, you can actually like check the attestation, this thing pops down, you get a little code hash, and then you go to like Intel's attestation service and you can check it, or NVIDIA's attestation service, and that's pretty neat. So it's like, you can verify it. You do not need to trust us. We can't see anything. We also don't want to see anything because people put really weird stuff in these chats. And I don't want to touch that. And so we do provide like enterprise guarantees. So service level agreements, these are critical for working with like very important organizations, and even things like, 15-minute response times if you pay us money. So that is a critical thing. That's the first product. That's what I mainly work on right now, is private inference. A use case of private inference is the chat. This is for everyone to use. You can go to chat.near.ai and try it out yourself if you want. And it's pretty straightforward. You pick the model, thing drops down, you talk to it. That's about it. There's a lot of other cool stuff that we're adding here, you could see where Nano Banana started editing my slides. You can see private memory is actually the next piece that we're building, that we're going to actually include into private chat, where you can move your context from chat to chat. And the cooler piece here, I forgot to add a very important word here, is portable. You're able to move your memory from OpenAI to NEAR chat or Anthropic or whatever. And even after, but it's going to be backed by a NEAR account, because everyone's like, oh, wait, why is NEAR Protocol or NEAR Foundation building all this AI stuff? Well, it's all going to come together where your NEAR account is going to be your ID. And if you guys don't know, every wallet on NEAR is by default a smart contract, and they're all human readable. And so this is a fantastic framework to essentially manage access control really easily, where everything is readable. And so the goal is to have all your data live in this private place. So when you ask your agent to say, hey, please go buy me a coffee, it understands that you like a certain type of latte. And it's not just going to order you whole beans or, ground coffee. Because if you don't understand, if it doesn't know, it's just going to order you, well, whatever the hell you want. So that's something that's being built right now. If anyone is interested in becoming a design partner for this project, it is mostly built, but we're looking for people who want to test it and want to incorporate this into their existing applications. Feel free to hit me up after this. It's a pretty cool opportunity to be a part of something neat early. In terms of the architecture, we're pretty much just running a private vector database inside of a TEE, and then have some additional storage. So, you are able to store larger files and do things like, hey, I want to scrape every single interaction I have on my desktop or every single interaction I have on my browser. And this thing can truly know what I do, and it is private. So that is pretty neat, and you'll be able to search things, share things, save things. Again, just want to repeat, if you're interested in this, feel free to hit me up after the fact. The next thing is something called Shade Agents. This has been around for a couple months now, and this is a bit more of a crossover between crypto and AI. This is not being built directly by the NEAR AI team. It is being built by a team called Proximity Labs. This is a spin out from NEAR from a long time ago. And they are essentially enabling agents to interact with any agent in a verifiably private way while maintaining and accessing crypto wallets. Not just any crypto wallet, but a chain abstracted crypto wallet. So you're actually able to say, hey, agent, I want to transact on Solana or transact on Zcash or anything else using NEAR's chain signatures. I'm not going to get into that right now, but in short, it's chain abstracted crypto agents. And the cool thing here is they're running inside of these black boxes, these TEEs. And so you're able to verify the activity of them without having to open source all the code, which is very important if you're an agent developer, because, love open source. We should try to open source as much as we can. But a lot of people's businesses depend on agents their business not being completely open. And so you can build that trust with your users without having to give them, everything. So that's a really cool thing. If you're building agents and want that extra layer of verifiability, this is a great framework to build with. And again, you can hit me up after if you're interested in this. This is pretty much how they work. Again, they can access all different chains. The goal is to completely abstract all that complexity away, and you can add any external APIs in there as well. So think of it, connecting to MCP servers and getting access to tool calls is very easy with this framework. You kind of get the point. I said that. And then the last piece is growth. So we need to actually get this into people's hands. And so this is where I'm working closely with a lot of robotics companies. The robotics use case is fascinating because a lot of robots, you don't want to throw super expensive hardware on them. It's going to increase the cost and limit access. And so a great way to actually ensure that your home robot is not leaking all of your personal context to OpenAI is to use NEAR AI's private inference. So it essentially takes all the sense data around it, turns it into text, sends it to our private cloud. Everything gets processed. The response goes back to the user. the robot interactions between you and the robot, not you, Sam Altman, and the robot, which is important if it's in your house. And so very interesting use case in robotics. I mentioned healthcare. Again, a lot of these companies can't use ChatGPT. OpenAI did just come out with a cool new like health agent, but I'm kind of skeptical because they're not HIPAA compliant, which is interesting. That's a long conversation. And then governments. A lot of governments don't want to have user data and any information in the United States. And so they do not, they want to run everything inside of their country on their own data centers, but a lot of times they don't have the energy deals, they don't have the power supply, they don't have everything else to do that. And so a better way to, we're kind of working with governments is to have these models run inside of this trusted enclaves, provide them an API key, and they're able to use their own custom model in a private way, which is neat. There was an announcement made with Brave browser. We are currently working with them. It's in Nightly, which is their test environment. So all NEAR AI, right now it would be one model, will be made available through the Brave browser. And so for those who don't know, a lot of browsers these days are trying to become agentic. A lot of these AI companies are launching their own browsers because, well, the browser is a lot of times the interface of people and the internet. And so a really cool sort of future direction is having these agents live in the browser using private inference to action on your behalf. This is a long journey ahead. Brave is super diligent on security, and yes, they are constantly asking questions. And so this is really, really cool. I'm very optimistic about this partnership, and it's a great distribution channel because I think they have 104 million users. And that'd be pretty cool if they all started using private inference. Tech companies, again, like a lot of tech companies don't just want to give all their information away and all their trade secrets to OpenAI. I personally see a world where all these giant tech, like these labs, are going to essentially recreate every business that are currently using them programmatically. And that's concerning. So a lot of these tech companies don't want to use their API. And what's cool about the NEAR AI is that you get cryptographic guarantees and not just a privacy policy saying, hey, we're not going to do this. A lot of these companies do have privacy policies saying, hey, we're not going to train on your data. They do store it. But I don't care about privacy policies. I want cryptographic guarantees. I see a world where superintelligence, if it's truly super intelligent, will exploit every vulnerability on the internet. And we need a way to move beyond privacy policies because the system will probably get overwhelmed with cases against them. So that's all I got right now. We're building a bunch of other stuff that I can't talk about, but the whole gist is private inference, portable memory, shade agents, and yeah, that's about it. Thank you, guys.
In terms of the private chat, right? So anybody can put the page up and claim that it's private. And so in this case, I have to trust NEAR that the data isn't going to be stored. Is there a way to build it in a way that I can actually guarantee that this data is actually going to be private and not stored anywhere? Like, I realize it's a hard problem, but still, I think if a claim is that a chat is private, that I need to be really confident that the data isn't going to be stored anywhere.
So that's where everything is encrypted, and that's where we use the TEEs to give you the hardware attestations where you're able to check yourself that this thing has been encrypted in storage, in transit, and everywhere else, and you get sort of a verification along each path. The second option is you can fork the front end and run your own front end and use our private inference network.
How much overhead is added compared to centralized LLMs or agents rather, when you have these overheads of attestation, the encryption, all of that?
Yeah, sorry. I talk really fast. It's about 5%. Yeah. And it's getting smaller and smaller. There's a lot of interesting inference optimization that's being done to decrease that.